Hey y'all, so today we're going to learn how to factor quadratic trinomials where the a term, or this leading coefficient, is not 1. So last time we learned how to factor things like, let's say like x squared plus 7x plus 12, where the a value, or this initial coefficient, this leading coefficient, was 1, and the strategy we used was to make a big X, put the c term on top, the b term on bottom, and then try to figure out two numbers who multiply to give me 12 but who add up to give me 7. And after thinking about it for a while, you should come up with 3 and 4, and then we can go ahead and write our factored form, which would be x plus 3 times x plus 4. X plus 3, there we go. So this is what we went over last time, and today we're going to look at a little bit more complicated ones where the a value is not 1. So there's a little bit more to it. So let's take a moment to practice a few of these big X's, just kind of get in that frame of mind before we jump into examples here. So the first thing I'm going to do is this left one's not really set up correctly, so I'm just going I'm going to go ahead and just straight up delete that one. So for these last three, what I'd like to do is just have you come up with two numbers that multiply to give you the top number and add up to give you the bottom number. So as we go through these, just pause the video, see if you could do it on your own, and then unpause it and see if you got the right answer. Okay, so a little spoiler alert, we're going to go ahead and go over the answers here. So two numbers that multiply to give me 24 and add up to 10 would be 6 and 4. 6 times 4 is 24. 6 plus 4 is 10. So again, pause the video, see if you can get this next one, and you might as well just try to do both of them. I think we'll just knock them all out together. So for the second one, we're trying to come up with two numbers who multiply to give me negative 40 but add up to negative 6. Here, when the product is negative, that tells you that the two numbers, or one number has to be positive and one number has to be negative. And then since they have to add up to a negative, that means I hate to use the word bigger because that's not really appropriate here, but the bigger number you want the bigger number to be negative, so that when you add them up, you end up with a sum that is negative. So two numbers, let's see if we could think of it here. We got, we could do negative 10 and 4, because negative 10 times 4 is 40, negative 10 plus 4 is 6. Let's do the last one. We need two numbers whose product is negative 48 and whose sum is 2. So we could do something like, we could do 8 and negative 6 will work, because 8 times negative 6 is negative 48, and 8 plus negative 6 is 2. So we've done a bunch of these. You did a lot of these in the last lesson, but we're going to use this little trick a little differently for when the a value is not 1. So when this a value is not 1, there are basically two kinds of problems that you're going to find. The first one is one that has a GCF, okay, so one that actually has a greatest common factor. So in this one, you'll notice that each of these coefficients is divisible by 5. So our GCF here is going to be 5. And what that means is we can actually divide out a 5 out of each one of these, just like we would factor out a GCF like on the first day. So this was day 3. Day 2 we went over factoring quadratics where a is 1. And the first day we looked over how to factor a GCF, and also got a little preview of what factoring by grouping is all about. So once you find your GCF, you're going to divide each one of these by 5. So I'm going to say, like, hey, divide by 5, divide by 5, divide. Well, let's see if I can just do it like this. Yeah, we're just going to divide each of these terms by 5. Okay, and it's not like that 5 just goes away. I'm effectively factoring it out, so it's like using the distributive property but backwards. Okay, so like if I were to distribute this 5 into this polynomial, I should end up with the 5x squared plus 15x plus 10. Now, once you factor out that 5, again, it doesn't disappear. You still have that factor of 5 all the way down until you're done. But now factoring this trinomial on the inside of the parentheses becomes a little easier because now the leading coefficient is 1. So we can go back to this little trick up here with the big X and finish it off. So I'm going to go ahead and draw my X over here. And I'm going to put 2 on top, 3 on the bottom. When the numbers are real small like this, it's usually easier to figure out. In this case, we want 2 times 1 is 2, 2 plus 1 is 3, so we get x plus 2 and x plus 3. So the way that we would write our factored form here is 5 times x plus 2 times x plus 3, just to kind of clean that up a little bit. Okay. Let's see if I can move that up a little bit. It's not going to let me. That's okay. Oh, there we go. So that would be our final answer. Let's see here. Let's make this red. Oh, nope. Doesn't like it. Does not like that at all. There we go. Okay, so that would be our final answer. So yeah, factor the remaining triangle. Oh, they already had it set up over here. I didn't even notice. So this is really you know, what you want to do. I guess I could replicate that over here just for the sake of completing the notes. There we go. And that's it. So the first thing you want to look for is that GCF, because if you can factor out a GCF, it makes the whole process a ton easier. So these first couple of problems are just going to be examples where that occurs. Now later we're going to look at problems like this where, notice there is no GCF here other than 1, right? Like, so we've got 2 whose factors are, well, just 2 and 1. 11's prime, so 2 and 1. 12's got a bunch of factors. It's got 1, 2, 3, 4, 6, 12. But this 11's kind of causing issues, right? Like, it's not divisible by any of the non-1 factors of the other 2. So we won't be able to factor out a GCF on that. We're going to have to handle that completely differently. I'll show you how that works in just a few minutes. Let's practice this whole GCF thing. So as always with these problems, you know, I really encourage you to try to do it on your own first and then double check. Let's at least go through number 1 and then you can try number 2 and number 3 on your own. So number 1, you want to check for a GCF, and you really always want to check for that GCF first because if you find it, it'll make your problem easier. So we don't have a whole lot of options here because 3 is prime, so it's just whether or not these are divisible by 3 or not. And 30 is, and so is 27. So that means that we have a GCF of 3. I'm going to just make a little note. My GCF is 3. So since my GCF is 3, I can go ahead and rewrite this as 3 times n squared plus 10n plus 9. And if you're a little confused where those numbers came from, basically what I did is I just divided each of those terms by the leading coefficient. So like I divided this by 3, I divided this by 3, I divided this by 3. And what I'm essentially doing here is doing the distributive property in reverse. So I'm taking out the 3 from each term. So that if I were to multiply this 3 back in there, I would end up with my original expression. Now that I've factored out the GCF, I can go ahead and do my x and try to factor the rest of this because now the coefficient on this trinomial is 1. I'm still going to have that 3 kind of sticking out there, but I'm going to have 2 more factors. Put 9 and 10, and remember, if this number is just bigger than this by 1, then that's always going to end up with this and then a 1. So my 2 factors are going to be 9 and, oh wow, look at that. That is the ugliest 9 I think I've ever seen. 9 and 1. 9 times 1 is 9. 9 plus 1 is 10. So let's go ahead and let me throw a little equal sign on there, and write our final thing here. This is it. It's going to equal 3 times n plus 9. Oh, look at that. It didn't, oh, there we go. And then n, oh, we don't want that to be caps. What's going on with my keyboard here? Oh, geez, I'm really slipping here. Plus 1. We don't want that. Okay, I'm not sure what's going on here. But anyway, yeah, so we get 3 times n plus 9 times n plus 1. That is now totally factored. So that's going to be our final answer here. So all this work out here is just really just scratch work. This is really where the good algebra is, where we're dividing everything by 3 to show that we're factoring out the 3, and then we use this big X to factor out the rest. So take a moment, pause the video, see if you can do number 2 and number 3. I'm going to work through those a little bit faster. Yeah, so go ahead and pause it and see if you can get it right. Okay, so for number 2, our GCF here is going to be 4. So we need to divide each thing by 4. We'll divide this by 4, we'll divide this by 4, we'll divide this by 4, all 3 of these by 4. And that will give me, let's see, 4 times a squared plus 2a minus, and then 140 divided by 4 is 35. So minus 35. Okay, so there we go. And so after that, we need to do our little big X. We're trying to find 2 numbers that multiply to negative 35, add up to 2. And that would be 7 and negative 5. Now it doesn't really matter which side it goes on, but I'm going to suggest that if you do have one positive and one negative, that you put the negative one first. And it's going to seem like it doesn't really matter, and technically it doesn't. But with what we're going to do in the next section, it might make it a little bit easier if you're just consistent about putting the negative one first. Now if they're both negative, you're kind of out of luck. It doesn't really matter which one you go. But if one's positive and one's negative, it will pay off later if you do the negative one first, even if though there's no like technical difference between it. Like if I wrote this as a plus 7 and a minus 5, still the same thing because multiplication is commutative. But later on, when we do this factoring by grouping stuff, it will make a little bit of a difference in terms of the ease of doing it. So in number 3, we get a GCF that's equal to 3, okay, which is pretty obvious here, I think. Now you don't always have a GCF, so don't just think, oh, I'm definitely looking for a GCF. Only factor out the GCF if it actually exists. So after I factor out the GCF, and again, what that means is I'm basically going to divide all of these by 3. Get that out of the way. So I'm going to divide this by 3. Oh, geez, what an ugly 3. Writing with this mouse is not as easy as it looks. And maybe I'm not making it look that easy anyway. But okay, so yeah, we got 3 times, and then after I divide each of those by 3, I'm going to get x squared minus 2x minus 8. And so that is the trinomial I'm going to be looking to factor. I'm going to do my little trick here. I got negative 8, negative 2. So 2 numbers that multiply to give me negative 8, add up to negative 2, and that's going to be negative 4 and 2. Okay, so let's write our final answer here. We got, don't forget that first GCF factor, we got 3 times x minus 4 times x plus 2. And so those are the 3 factors of this problem, and this is completely factored. So these 3 problems are examples of situations where you actually do have a GCF, or a greatest common factor. And anytime you're factoring, you always want to try to factor that out first. It will just make the rest of the problem easier because it's just going to make all your numbers smaller. So dealing with 140s and 27, you don't want to really deal with numbers that big if you can help it. So you want to go ahead and factor out the GCF, and then usually you can do this little trick afterwards. So that's factoring using a GCF. Now let's take a quick look at how to factor a quadratic trinomial where the a value, or that leading coefficient, is not 1, Let's see how we would do that. So take a look at this. 2x squared plus 11x plus 12. The leading coefficient's not 1, and there's no GCF to speak of here. I can't divide this by 2, so 2 is not going to work. So here is the strategy on how you factor something like this. It's a little bit more involved, so I'm going to take this first one especially very slowly, and I'm just going to talk through all the steps. So the first step that you need to do is you need to bring down the first and the last term. So I'm just going to draw some arrows here. Notice I'm not going like directly down because I'm going to need some space in between. But I'm going to make a little equation here. So this is going to equal, let's see if we can make this a little bigger. I feel like this text is just not really cutting it in terms of the size. That might be a little better. Okay, so it's going to equal 2x squared, and I'm just going to put a ton of space here if I can. Oh, it's not going to let me. So for now, I'm just going to do like plus 12 over here. I'm not sure why my document's kind of freaking out here. Okay, so notice I just brought the first term and the last term down. The next thing I'm going to do is I'm going to break down this middle term right here, this 11x. So when I say I'm going to break it down, I am going to find two terms that add up to negative 11. So when you think of that, you know, there's infinitely many combinations, right? Like you could do 1x plus 10x, or 2x plus 9x, or 5x plus 6x. You can even throw in some negatives like 12x plus negative 1x. And it doesn't take long to realize that there are infinitely many combinations to do this. But there is only one combination that will work with this grouping method that we're trying to use for factoring. So what we want to do is we want to be able to find two terms that add up to 11x, but that work with this grouping method. So it sort of begs the question here, although that's probably not the right not usage of that phrase, but you know, how do you come up with the correct two terms? And it's going to come back to, of course, our big friend, the big X. We're going to put 11 on the bottom, but we're going to be careful here. Okay, so just like in the previous types of problems, you're still putting b on the bottom, but on top, you're actually going to put not just the 12 here, but 12 times 2. Okay, so the leading coefficient times the constant. So I'm going to put 24 up here. Okay, and if you think about it, we were actually doing that all along, right? Like on this example up here, 1 times 12 is 12. 1 times 2 is 2. 1 times 9 is 9, and so forth. So we've actually been doing that all along. It's just that I didn't really mention it because that first coefficient was always 1. But now that it's not 1, we need to actually pay a little bit closer attention and say, okay, well, this number up here needs to be the leading coefficient times the constant. Now, the big X game is still the same. We're still trying to find two numbers whose product is 24 and whose sum is 11. It's just that the purpose of the game here has changed. Okay, what I mean by that is that we're going to use these two numbers not as like our final answer, but as a way to break down 11x so that we can actually do this factoring by grouping. So the two numbers that multiply to give you 24 and add up to 11 are 8 and 3. So 8 times 3 is 24, 8 plus 3 is 11, so we're good to go. Now, how that comes into play here is that is going to be how we split up this middle term. So I'm actually going to split up 11x as, let's see if I can get this to come up here. I don't know what's going on with this big old box here. It's kind of getting on my nerves. 8x plus 3x. Okay. So let's put that like right here. All right, so what we have here is a new expression which is equal, and I'm just going to rewrite it, kind of bring it all together here. 2x squared plus 8, oops, let's not stay in the exponent there, plus 8x plus 3x plus 12. Now, this may start looking a little familiar because we are going to use the grouping method that we learned on the first day's lesson. Okay, so just to kind of recap how to do that, so once you get this polynomial as a 4-term polynomial set up like this, typically you can go ahead and factor by grouping like we did on day 1. So just as a reminder, we are going to group the first 2 terms, and we're going to group the second 2 terms. We are going to factor out the GCF out of each group, and we'll go from there. I'll explain once we get that far. So the first group is the 2x plus 8, 2x squared plus 8x, and the GCF of that group is 2x, because I can divide out 2x out of each of those terms, and that would leave me with x plus 4. In other words, if I were to distribute, like use the distributive property here, and let me throw an equals on there. If I was to use the distributive property there and multiply the 2x like back into it, 2x times x would be 2x squared, 2x times 4 would be 8x, and we'd be good. So we know those are congruent, equivalent rather. In the next group, our GCF is 3. So I'm going to write plus 3, and I'm going to divide out 3 out of each of those terms. So I get x plus 4. Now this is where you're going to stop and make sure that you're doing it correctly. And the way you know that you're doing it correctly is that both binomials in the parentheses must be the same. So if they're the same, we're in good shape. And just do a little check mark here. Okay, I checked it. We're doing good. And then we're essentially done here. Okay, our 2 factors are going to be, well, first that factor that appears twice, that x plus 4, and then your second factor is going to be all the stuff that's left over. So what I mean by that is the 2x plus 3. And there you go. That's your answer. This is the factored form of this polynomial. And so there are definitely a few more steps than what we've been doing, but and it'll take a little bit of practice, okay? But what this does is basically it merges everything that we learned on the first day with everything we learned today so far, or on the second day rather. So let's go through some examples here. Let's just knock out what we got. 1, 2, 3, 4, 5. We got 6 examples, and I think really what you want to do is just like work as many of these out as you can. Make sure you practice the practice problems because they're not that easy. Okay, they do take time, and it's not like a process that's super intuitive unless you've done it a few times. So we're just going to do these one at a time, and I'll just kind of explain all the steps here. So the first thing we want to do on all these is we're going to bring down the first term, the last term, and we are going to split up that middle term using the big X. So let's figure out how to split up that middle term first. So I'm going to make a little big X over here. It doesn't have to be that big, but on top, 2 times 9 is 18. Okay, so remember that leading coefficient times the constant, and then the linear coefficient, that middle term, that b, goes on the bottom. So here I'm looking for 2 numbers that multiply to give me 18 and add up to 9. Those are going to be 6 and 3. So that's how I'm going to split up the middle term. Those are my 2 magic numbers there. So the first term stays the same. Okay, it's still 9w squared. The second term gets broken down. Okay, it's not just 9w anymore. It's 6w plus 3w, which, if you were to simplify it, is 9w. So it's not like it's not equivalent or anything. But that's the only way we can set this up for factoring by grouping. And then the plus 2 is it is just what it is. Okay, so I'm going to do plus 2. So now we've got this set up as a 4-term quadratic polynomial, and now we're going to do the grouping. So we're going to group the first 2 terms and the last 2 terms. In the first 2 terms, my GCF is 3w, which leaves me with 3w plus 2. And then that second term, you might think, okay, well, hold on here. There's no GCF in that second group, and you're right. So let's go ahead and do plus 1, because 1 is a factor of anything. So if we, in other words, if we were to just distribute that 1 into the 3w plus 2, we'd get the same thing, right? 1 times 3w is 3w, 1 times 2 is 2. So it's not like that changes anything, but that's going to allow us to find our two factors. Our two factors here will be, first of all, the one that appears twice. So let's stop and make sure they are actually the same. We got 3w plus 2, 3w plus 2. We're good. So that means that one of our factors is 3w plus 2. And our second factor is 3w plus 1, which is the two things we factored out, right? The sum of the two GCFs. And those are our factors. On number 5, same process here. Okay, so I'm going to make my big X. I'm going to put 24 on top because that's 6 times 4. And I'm going to put a negative 11 on the bottom. And I'm looking for two numbers that multiply to give me 24 and add up to negative 11. So they both have to be negative to make that combination work. So let's think about this. I think what we're going to go with here is negative 8 and negative 3. Okay? So the first term and the last term stay the same, but I'm going to split up that middle term. So I like drawing these arrows just to kind of remind me what's really happening here. You don't have to draw the arrows, honestly, but it doesn't hurt. Let's bring this over there. So we got equals 6k squared minus 8k, oops, minus 3k plus 4. We're going to look at the first two terms and the last two terms. We're going to group those up. Now, what we want to make sure happens is that we get the same thing in the parentheses, like on this last one. So let's just keep in mind that as we're going through this. So the GCF of that first one is going to be 2k, which leaves me with 3k minus 4. And if you look at the next set, it might be a little confused here because, take a look at this. We got minus 3k plus 4, but we want it to be 3k minus 4. So what we can do to sort of flip these signs is to actually factor out a negative 1, which would flip both signs. Negative 1 times 3k is negative 3k. Negative 1 times negative 4 is positive 4. And not only does that fix our signs, but it also ensures that we get the same thing in both of these sets of parentheses. So our final answer here will be 3k minus 4 times 2k minus 1. So that's number 5. Again, if you got any questions on any of these, we've got really just 4 more examples that I want to go through with you. But if you're still really confused after going through these, just hit me up in the Google Meet, and I'll definitely help you out. All right, number 6. 12 times negative 2 is negative 24. I'm going to put 5 on the bottom. So we need to come up with two numbers that multiply to negative 24 but add up to 5. So one's got to be positive, one's got to be negative, and the positive one has to be bigger if my sum is positive. So that's going to be 8 and negative 3. So negative 3 and 8. Now, going back to what I was talking about earlier, the negative 3 I'm going to put first here, because if I don't, then I'm going to have to factor out a negative on the second group, and ideally I want to avoid that if I can. So you can see here, like, if I flip these and do the plus 8a first, the big problem with that is that, well, it's not really a big problem, kind of overstating it, I guess, but the issue is if you have the negative 3a here, then you're going to have to remember to factor out a negative, whereas if you put the positive one here, then you don't have to worry about that. So just one less thing to deal with, and I'm all about finding less things to worry about. Okay, so let's take a look at that first group, this one right here. The GCF is going to be 3a, and the GCF on the second one is just going to be 2. So I'm going to factor out that 3a out of the first one, which leaves me with 4a minus 1. Whenever a term is its own factor, when I divide that out, I do get 1. So just, that's why this is becoming 1. 3a divided by 3a is 1. Plus 2 times 4a, again, it happens again, minus 1, which is good. That's what we want to happen, right? We want these two things inside the parentheses to be the same. So now we can write our final answer, which is going to be the first factors, that one that we see duplicated there, the 4a minus 1, and then we find the sum of the GCFs that we factored out, which is 3a plus 2, and now we've got two factors whose product is the original expression. Number 7. We're going to put negative 9 times 5 is negative 45 on top, 12 on the bottom. So let's try to think of two numbers multiply to give me negative 45, add up to 12. Since they multiply to give me a negative, one of them has to be negative, one of them has to be positive. So I'm going to put my negative one first just to make the rest, make my life just that much easier. And so I think what we get here is 15 and negative 3. So the way that I'm going to write my next line here is I'm going to say 5t squared, remember that first term doesn't change, minus 3t plus 15t minus 9. And I've said this probably about 10 times so far, but these two terms, we're getting that by splitting up this middle term in a very specific way so that grouping will work. If you get these two numbers wrong and you split up that middle term incorrectly, odds are, I'll just go ahead and say you'll definitely not be able to factor it correctly. So the GCF in that first group looks like it's just t, so that leaves us with 5t minus 3, and the GCF in our second group is 3, so I get 5t minus 3. Those two binomials in the parentheses are the same, looking pretty good here, so we get 5t minus 3 and t plus 3. You might notice on each of these problems I'm sort of writing less and less. And that's just because as you go through these, a lot of these little notations that I'm writing here, the arrows, the underlines, is really just to help me explain where everything's going. So, if you really want to see that notation, just go up and look at the first few problems. But eventually you want to get to a point where you just know what you're supposed to do, what you're supposed to look at, and then your work will look more like this, a little cleaner there with no underlines, no arrows or anything like that. Honestly, eventually, I wouldn't even say this year, but by the time you do Algebra 2 and you practice this a little bit more, you'll eventually get to a point where you don't even have to show all this. Like, you'll just know what you're trying to do. Say, okay, well, two numbers that multiply to give me negative 45 add up to 12. You might have to do some scratch work if those numbers are a little big, but overall, the real algebra are these steps right here. So this is really like the critical thing that you got to write down. Okay, last two problems here. Number 8, so let's see what we got here. Now number 8 is a little tricky. When you've got that leading coefficient negative, it's not something you have to do necessarily, but what I really think makes this problem a heck of a lot easier is if you factor out a negative 1 right from the get-go so that the trinomial that you're trying to factor is only dealing with positives. There's just something about negatives that make them just a tad bit harder to work with. I think if you, sort of literally take it out of the equation or expression, it just will make your life easier. So now I don't have to worry about negatives. I'm still going to have this negative 1 just kind of trailing out there for the whole problem. But let's see, 1 times 3 is 3, and then 4. So I'm looking for two numbers that multiply to 3, add up to 4. It's going to be 3 and 1. So don't forget about that negative 1, though. It's still there. And what I've got now is 3r squared, not t. If I could use the keyboard correctly here, that'd be nice. Plus 3r plus 1r. So, usually don't write the 1r. I'm going to leave it there for now. Usually you just see it like that. But it doesn't hurt at the moment. Although I wouldn't really want to write my final answer using that. Okay, so now I'm going to group the first two terms and the last two terms. You're still totally ignoring this -1 out here. It's still going to like fall down on each individual step, but it's not really going to affect anything that we do from here on out. So let's see, my GC, well, now I got to be careful with my parentheses here. Okay, so what I would usually recommend now, since we're going to have parentheses in parentheses, is to use brackets for the outermost parentheses. So I'm going to factor out the 3r, and we get we get r plus 1, and then we can factor out a 1 out of the second one and get r plus 1. So the brackets just serve as like parentheses too. They don't operate any differently than parentheses do when you're writing them. But the advantage is that if you use parentheses and brackets here, it's a lot easier to see what's supposed to match up with what. If all you do is just use a bunch of parentheses, then there's going to be some ambiguity about, you know, which open parenthesis matches up with which closed one. We won't need them for the final step here though, which is we're ready to go ahead and write our factors here, which are going to be r plus 1 and 3r. 3r, what am I doing here, plus 1. So there's your answer. Now if you did not factor out that -1 front, it's not a big deal. You would have just got a slightly different answer. If you did not factor out the -1 up front, then you would have gotten something, well, there'd be two options depending on how you do the rest of the problem. Either you would have got -r minus 1 times 3r plus 1, or you would have gotten you would have gotten r plus 1 times -3r minus 1. In other words, like one of those factors would have a negative distributed into it. So all these three they're congruent, okay? They're equivalent. They're the same exact expression, except this one is probably the most factored out. So just be aware that in factoring out this -1, it just makes the rest of the process a little easier. But these two down here aren't technically wrong, okay? They're equivalent. They are factored. So just know that I will usually factor out this -1 just to make the problem easier. But if you didn't, it's not that big a deal. Number 9. We got a GCF here. We got to take care of that GCF first, just like we do in number 8. So let's go ahead and do that. The GCF here, it looks like, is going to be 2. So I'm just going to factor that out right up front. And that gives me 5w squared plus 12w plus 4. So it looks like this is going to turn into another bracket problem here. So I'm going to have brackets. Well, I guess I don't need the brackets yet. 5w squared plus something. Just do a little, little space here. Oh, is it going to let me do a space? Yeah. Plus, nope, it's going to close. Okay. So I'm just going to have to wait on that. So let's go ahead and figure out what our special numbers are going to be. 4 times 5 is 20. And then we've got 12 on the bottom. So this one shouldn't be too hard to figure out. Factors of 20, looks like 10 and 2. We'll get the job done here. 10 times 2 is 20. 10 plus 2 is 12. So let's see. Let's go back to this equation. So we should have 5w squared plus 10w plus 2w plus 12. Notice how I kept the first and the last numbers the same, right? This is the same. This is the same. It's just that middle term that I'm splitting up so that this factoring technique will even work. If you don't do this, the factoring by grouping technique is just sort of dead in the water. It doesn't really work unless you do this. So now that I've got those 4 terms, I can actually execute the grouping technique here. So I'm going to have equals 2, and I'm going to swap these over for brackets just because I know I'm going to have parentheses on the inside like I did over here. The GCF of these first 2 terms is going to be 5w. So 5w times w plus 2. And then my GCF of the second group is going to be 2. So I'm going to write plus 2. And that's going to leave me with w. Wait a minute. Something's not right here. Plus 6. Uh-oh. We might be in some trouble here because we checked these and these are not the same. Okay, so let's take a moment and see, did we make a mistake somewhere? hold up here. Oh, I see exactly what happened here. Look at this. This 4 was supposed to stay a 4. Oh, how embarrassing. So yeah, so this is, I'm actually kind of good. I made this mistake just so you can kind of see it happen in real time. If you notice these two things in parentheses are not the same, that should throw up a little red flag. In fact, I'm going to draw a little red flag right here. Hey, something's up. Something's not right. Okay, that's my best drawing of a red flag. I'm not going to spend more time on that. But anyway, yeah, this should have been a 4, right? I'm supposed to bring down that last term. I'm not sure why I wrote 12 there. Maybe I just looked at this and wasn't really thinking. I'm sure we can all identify with that, just like you kind of space out as you're working a problem. Okay, so anyway, I factor out that's 2 here. 4 divided by 2 is 2. And now, okay, now we're in business here. I was a little worried there. We didn't get the same thing, but we're okay. So we got 2 times, let me use the equation. It just looks a lot nicer when you do that equation function. 2 times w plus 2 times 5w plus 2. Those are going to be our factors. And that's pretty much it for today. Okay, so we did a bunch of examples of how to factor by grouping. I know this technique takes 2 or 3 extra steps than if this number is not a 1. So you're kind of hoping this leading coefficient is 1, because if it is, your life's going to be a lot easier. If it's not the end of the world, but you just but it's not impossible either. Okay, you're still going to use this big X, just in a slightly different context. Remember that you're going to multiply the first and last terms to get this top number. Okay, so it's not just about that last number like it was when A was 1. I mean, technically you're doing the same thing on both. It's just that if A is 1, it doesn't really affect it, so I didn't really mention it. But just keep in mind that is where that top number is coming from. Well, y'all have a great day. Good luck working on these practice problems, and let me know if you guys need anything.